Hey everyone. So in this video, I like to briefly talk about interval notation. So in this class, we'll frequently want to refer to a continuous set of numbers, and one way you might be familiar with doing this is through inequalities. Right? So let's say I've got the inequality 5 is less than x is less than or equal to 12. Right? So this is describing the set of numbers between 5 and 12, and here maybe I'll depict this with the number line. So this is describing the numbers between 5 and 12. So all these numbers here on this number line. But it's also saying a little bit more, right? It's saying that x cannot be the same as 5, right? X must be strictly bigger than 5. So here, one way we can kind of depict that on a number line is we plot sort of an open circle there at 5. And then here we're saying that we're allowing x to also be equal to 12, right? That's kind of a valid point we're considering. Right, so this inequality is describing the continuous set of numbers between 5 and 12, not equal to 5, but possibly equal to 12. And so interval notation, it's kind of a more compact or concise way of saying this exact same thing, right? So if you look at this inequality, you notice that really all we're looking at here is, all we need to really say here to know the interval we're talking about, to know the set of numbers we're talking about, we really just need to know sort of the lowest value, the lowest boundary to this set of numbers, 5. And the largest boundary to this set of numbers, 12. Right, if I told you the numbers between 5 and 12, you know more or less what I'm talking about. There's also this extra information of whether or not we include 5 or 12. But if we can capture all of these pieces of information, we really know the set we're talking about. And so this is what interval notation sets out to do. So interval notation, really what it does is exactly this. It just says the lowest value, the lowest boundary value, and the largest boundary value for your set of numbers. And so in this case, in interval notation, we'll say the lowest value, we'll say 5 separated by a comma, and we'll say 12, the largest boundary value. But we also need to be able to describe whether we're including these boundary values or not. And so we'll typically say, we'll use a parentheses. Maybe I'll just say it in words. So parentheses are used to describe excluding that boundary value. And then brackets, square brackets, are used to describe including the boundary. Right, so by parentheses, that's these symbols, and then brackets, I mean these symbols. So here above, we're kind of saying, exclude the value of 5 from our set, or our continuous set of numbers. We'll wrap that with a parentheses on the left. And then we want to include the value of 12, so we'll wrap that with a bracket. Right, so really, this interval notation here, right, this is kind of saying that, this is saying numbers greater than, strictly greater than 5. Right, that's what this parentheses 5 means. And then here, this bracket, this 12 and this bracket together, this says, this kind of means but less than or equal to 12. And so So that's an example of using interval notation to describe a continuous set of numbers. Here, maybe let's go through a handful of different examples just to see all the different ways this can sort of take shape. So, if I have an inequality, let's talk about the corresponding interval notation. So we already have one example. We have 5 is less than x is less than or equal to 12, and we know that that tells us that corresponds to 5 or parentheses 5 comma 12 in brackets on the right. And again, we always want to include that, that smaller value on the left, the larger value on the right. Okay, and so we can kind of reverse this statement, and I can reverse the inequality symbols and maybe have something like this. What if I had 5 is less than or equal to x is less than 12? Well, in interval notation, this would look like bracket 5 comma 12 in parentheses, right? This is saying the numbers that are greater than or equal to 5, right? So bigger than 5, but maybe equal to 5, but less than, strictly less than 12, not equal to 12. And so based on these ideas, what would you anticipate, what would you expect, bracket 5, comma 12, close bracket. What would you expect this to represent as an inequality? Well, this is saying the numbers between 5 and 12, possibly including 5, possibly including 12. And the other end of the spectrum is if we have 5 is less than x is less than 12, right? This is not allowing for our value of x to be equal to 5 or 12. So here, this is saying, numbers between 5 and 12, but not including 5, not including 12. So, we can often write other types of continuous sets of numbers. In interval notation, sometimes we'll encounter this idea of sort of unboundedness, right? We might have something like, if I have the inequality x is less than or equal to 5, right? This is saying all the numbers smaller than 5, right? And here this is saying, in some sense this is saying that the largest value x can be is 5, but there is no smallest value, right? It's kind of unbounded in how small this value of x can be to satisfy this inequality. Right? And so to capture this in interval notation, here we would have a negative infinity to sort of say there is no limit to how small x can be. Right? There is no lower bound, but the upper bound would be 5. And here we're allowing for equality with 5, so I'm going to include a bracket there. Whenever we're using whenever we're using infinity or negative infinity in interval notation to describe unboundedness, we wrap that in parentheses. And the main reason is because infinity is not actually a number to include or exclude, and so it doesn't really make sense to include a bracket there. And so infinity plus or minus infinity, when we see it in interval notation, it's sort of wrapped in parentheses every time. And so what if we write something like x is greater than 12? Right, so the smallest this set of numbers can be well, it can be any value near 12. It can't actually be 12, right? We're excluding 12, but the moment it's a little bit bigger than 12, that's okay, right? So 12 can kind of be used to describe how small the values of x can be. But again, this is not telling us a cap on how large it can be, right? So there's no largest value here. And so typically we'll write this in interval notation as, well, we know it can get as small as 12, but not 12 itself, right? So we will wrap it in parentheses. But there's no bound to how large our values of x can be to satisfy this inequality. So I'll write for my upper bound infinity to describe unboundedness. And then we'll wrap that in parentheses because we always wrap that infinity symbol in interval notation in parentheses. And then if you're just trying to describe all the set of all numbers in interval notation, if you wanted to talk about all real numbers, you're describing the whole entire number line. Well, there's no bound in either direction. This is expressed as parentheses negative infinity to positive infinity. So usually interval notation is pretty concise. I kind of feel like this example, it's not the most concise, but that's okay. It's consistent with the rest of the examples. Sometimes we'll want to join multiple intervals together. We'll want to refer to multiple intervals at the same time, and we join them together with this union symbol, this sort of uppercase U. Right, and usually we'll order our intervals from smallest to largest. So let's say I have the interval 3 to 7, excluding 3, including 7, and I wanted to join it with the interval 10 to infinity. I would just write this uppercase U between them. This is the union of these two intervals. And maybe to have a picture of what's going on here is really, here's maybe 3 on the number line, maybe this is where 7's located, and maybe here's where 10 is located. Really the picture to go with our interval here, or our joined intervals here, well, it's this open circle at 3, right? 3 is not included. All the numbers between 3 and 7, with 7 included. And then we have a space, we're not including the values between 7 and 10. They're not included in either of these intervals. And then we'll go ahead and not include 10, but everything larger than that we want to consider, right? It's being described by this interval notation. Right, so that's this corresponding set of plotted points on our number line that correspond to this interval, this pair of intervals joined together. And so maybe here, let's go ahead and do the reverse of this. Let's express this shaded part of the number line in interval notation. And so if you're up for it, feel free to pause the video and try this example out yourself first, but we'll go over it together in a moment. All right, so here, what interval notation does is that it sort of, it describes the sort of continuous pieces, continuous sets or chunks on your number line. So it describes the continuous pieces, maybe, I think that's fine. So it describes the continuous pieces on the number line. And we'll join these continuous pieces with our union symbol. So, the first continuous chunk is this chunk here. And this chunk can be expressed as the interval from negative infinity, right? It's unbounded on the left from negative infinity to -2. And we're not including -2 itself, right? And then what's the next continuous set of values that we're interested in? Well, the next continuous set goes from -2, again, not included, up to +1, right? It's this kind of chunk here. And we're going to join these together with our union symbol to describe our set above. But then there's one more set we're joining together. We're going to join this third interval. And here, because we've got these sort of filled in endpoints, we're saying 3 and 4, those boundary values, they're included in our interval notation. We can write this as bracket 3, comma 4, close bracket.